So now we'd like to discuss how we actually find the inverse of a matrix. To determine the inverse of a matrix, we're going to take the matrix that we're interested in and we will augment it by the identity matrix. So that means that I'm going to place the appropriate identity matrix next to it on the right-hand side, and we'll separate it with a vertical bar, as indicated right here. Now we're going to use row operations so that we can get the coefficient part of our augmented matrix to look like the identity matrix. So it'll be in reduced echelon form. So essentially we're trying to move the identity matrix from the right-hand side into the left-hand side. So at the end, we should have the identity matrix on the left, and then the terms that are on the right-hand side, those are the entries of our inverse matrix. So we're going to use row operations to reduce the coefficient part of our matrix down to the identity matrix, and then the right-hand side will be the inverse matrix. So let's see how this is done. So let's go ahead and start with step 1, which is augmenting the matrix A by the corresponding identity matrix. So matrix A, we have 1, 0, 2, negative 1, 2, 3, 1, negative 1, 0, vertical bar, and now we put in the 3 by 3 identity matrix. So 1, 0, 0, 0, 1, 0, 0, 0, 1. Now our goal is to have the right-hand side of our augmented matrix. We would like this to be the identity matrix. It's not right now. Currently, it is the original matrix A, and the right-hand side is the identity. But our goal is to reduce the left-hand side so it becomes the identity matrix. And we'll do that using row operations. So, first things first, we already have a 1 in the 1, 1 position, so now we need to clear out all other terms in that column. That means we need to take care of row 3. So we will take negative 2 times row 1 plus row 3, and this will go into row 3. So this gives us the next matrix, which will be 1, 0, 0, negative 1, 2, 5, 1, negative 1, negative 2, vertical bar, 1, 0, 0, 0, 1, 0, negative 2, 0, 1. Now notice that on the right-hand side, we have an adjusted identity matrix. So think back to last week, we talked about how multiplication by an identity matrix that's been adjusted can perform row operations. Well, that's exactly what happened right here. We did the row operation of negative 2 times row 1 plus row 3, and now our matrix on the right-hand side is illustrating that. So that's something to keep in mind, and that's why what we end up with on the right-hand side will be exactly the inverse matrix, because it's keeping track of everything we need to do to get back to the identity. Let's see, now we need to try to get a 1 in the 2, 2 position, so we need this 2 to be a 1, so we will do 1/2 times row 2, and that will give us the next matrix. So let's see, our next matrix then is going to be 1, 0, 0, negative 1, 1, 5, 1, negative 1/2, negative 2, vertical bar, 1, 0, negative 2, 0, 1/2, 0, and 0, 0, 1. Again, notice on the right-hand side, the fact that we divided by 1/2 is being recorded in that matrix on the right-hand side. So let's see, we need some more row operations. We're going to have to do, let's see, we need to make the negative 1 and the positive 5 zeros. So we will need 1 row 2 plus row 1, and this goes into row 1. And then we will also need negative 5 row 2 plus row 3, and this will go into row 3. Alright, so let's see. Our new matrix then will be the following. we should get 1, 0, 0, 0, 1, 0. And then the third column, we should have 1/2, negative 1/2, positive 1/2. And then on the right-hand side, we have 1, 0, negative 2, 1/2, 1/2, negative 5/2, 0, 0, 1. We're very close to being done. Now we need to look at column 3, and so we need the 3, 3 element to be a 1. So that means we'll need to multiply row 3 by 2. So we need 2 times row 3, and that gives us the next matrix. So let's see. 2 times row 3, we're going to end up with 1, 0. Oh. Let's see, I'll go ahead and draw it down here. We'll end up with 1, 0, 0, 0, 1, 0, 1/2, negative 1/2, 1, vertical bar, 1, 0, negative 4, 1/2, 1/2, negative 5, 0, 0, 2. And now we are so close to the end. We need the 1/2 and the negative 1/2 in the third column to be zeros. So we will take negative 1/2 of row 3, because we're pivoting on the 1 from row 3, and we will add it to row 1, and this of course goes into row 1. Similarly, we'll take a positive 1/2 times row 3 plus row 2, and this will go into row 2, leading us to our final matrix. And so we end up with, let's see, 1, 0, 0, 0, 1, 0, 0, 0, 1 on the left. Notice that is exactly the 3 by 3 identity matrix. And on the right-hand side, we get 3, negative 2, negative 4, 3, negative 2, negative 5, negative 1, positive 1, and a 2. Okay. So we have the identity matrix on the left, and on the right-hand side, we have our inverse matrix, A inverse. Because the matrix on the right-hand side has been recording everything that we did in order to get the identity on the left-hand side. So we can now say that A inverse is equal to 3, negative 2, negative 4, 3, negative 2, negative 5, negative 1, positive 1, positive 2. And that would be our final answer. You should, of course, verify your work with your calculator. So put in the original 3 by 3 matrix into your calculator, and then check that the inverse is the matrix that we found from doing this by hand. You should be able to find the inverse of a matrix by hand and using a calculator. I'll expect you to be able to do both of those on an exam or a quiz.